This question's very clearly a projectiles one. We've got a tennis player hitting a ball, aiming for a net over near position B. We've got an initial velocity of 45 meters per second, and that's in a direction 10 degrees below the horizontal. Below is quite annoying. It's not so often that we get those questions, but it's something to watch out for. So if we draw the horizontal at O, the initial velocity is in that direction, its speed is 45. And so we've got two components there from the 10 degrees. We've got 45 cos 10 degrees, that will be the horizontal. And because that's going downwards, I'm going to have negative 45 sine 10 in my vertical initial velocity. Okay, just a quick reminder on the side, when you're dealing with projectiles horizontally, you can just use distance equals speed times time, because that horizontal component of velocity is constant throughout the motion. Vertically though, we need suvat, because we've got free fall under gravity, we've got a equals minus 9.8 in suvat. It's possible to do these questions with vectors, but I just do everything horizontally and vertically separate. Okay, now we're given some vertical information and some horizontal information. We've got 12 meters labelled on the diagram. The net is 12 meters away horizontally, so I can use that to find time. Because the ball's going to come over here somewhere, but we don't know what height that's going to come in at, so we need to use the horizontal information first. So let's just label horizontally. Distance is 12, speed is 45 times cosine 10 degrees multiplied by the time, which I don't know. I can rearrange that to get t equals 0.2707 and a few more decimal places. Remember to keep quite a few significant figures there, because we're going to use it in our next step. Because we're trying to find more or less the height of the ball at that point, or how high it is above the net. So now we need to think vertically. We're trying to get S, so we'll probably use, when we think vertically, S-U-V-A-T. S is what I want to know. U, as we said before, is negative 45 sine 10. V, don't really care about. A is negative 9.8. And T, we've just found when we get to the net, T is 0.2707, ... So this is going to be S equals UT plus a half AT squared. I won't write all those numbers down again, but when you substitute that, you should get 2.4752. Again, we're keeping a good number of significant figures there. Now we have to remember what S means. S measures displacement, so where you are relative to where you started. So, in fact, sorry, that's going to be a negative value because it's negative on the calculator, and that's telling us that we're lower than where we started. We started at a height of 3.5. So we need to subtract the 2.4752. That will tell us how high we are above the ground. Then we also need to subtract the 1, which is the height of the net, to tell us how high are we above the net. There's not much space in there to draw it, but I'll just try and highlight in blue on the diagram that little gap there between the net and the ball. If you put all of that into your calculator, you'll get 0.025. But notice the question wants this specified in centimeters to 2SF, so that is 2.5 centimeters. So we've just cleared the net by 2.5 centimeters. Okay, in part B, we want to find the speed of the ball, right? Speed is one of these warning words in mechanics. Speed is the magnitude of velocity, and velocity's got two components. We've got horizontal, which is constant, and we've got the vertical one, which is changing. So the strategy for part B is to find both those components and then do Pythagoras on them. So we'll move down a little bit so we've got some place for working. So for part B, we're going to have a horizontal component and we're going to have a vertical component. And we're asked to find the magnitude, which is the speed. Okay, 45 cosine 10 never changes. Vertically, we want v. It's probably easiest to use v equals u plus at, because v is what we want. U is negative 45 sine 10. A is negative 9.8. Okay, we can calculate t, sorry, we know is 0.2707 from earlier. And we get a value for v there. I can't remember what it is exactly, it's 40 something. It's probably 10 something. Maybe I should actually do that on the calculator. But what we want to do is use that v that we've calculated in Pythagoras, 45 cosine 10 squared plus that v squared, in your calculator, and you should get 46 ms minus 1, because again, that question asked for the answer to be given to two significant figures, and they'll take a mark off if you don't do that. So 46 meters per second, so 2sf. Final part C, state two limitations. Air resistance, classic answer, and we need another one. Now you can't just say wind, because you can't have wind without air resistance, really. We could talk about the spin that affects the trajectory. You could talk about the physical size of the ball, because it's very close to the net, so depending on the size of that ball, it might actually hit the net rather than clear it when it's modelled as a particle. One other thing that you can't say, so let's cross out wind, because we've already said air resistance. You can't talk about the mass or the weight, because they don't affect the projectile motion. All masses will experience A equals minus 9.8, so that's not an option. You could talk about, some people talk about 3D motion, whereas we've modelled it as a 2D problem.